So welcome students. So in this question, you're given that there are three complex numbers a, b, c on the organ plane such that mod z1 is equal to mod z2 is equal to mod z3 is equal to 4. It means all of these complex numbers are situated on a circle whose radius is 4 units centered about the origin, because the distance of z1 from origin, distance of z2 from origin, distance of z3 from origin, all are 4 units. Okay, that means all these complex numbers lie on a circle with origin as center and radius is equal to 4 units. Now you have a complex number p, which is minus z2 z3 by z1. So you have a complex number on this organ plane. Now you're asked to find the image of this point with respect to the line BC. So what is the image of this point with respect to the side BC? So this is not a question where you need to solve things. So this is a question based on certain properties of triangles. It's a question based on properties of triangles. Properties of triangles. So there is a property in triangles, so which I'm going to state now, which we're going to use in this question. So if you have, the property says the property is something like this. If you have a triangle, so if you have a triangle ABC, the property says that the image of orthocenter, with respect to any side, lies on the circumcircle. The image of orthocenter with respect to any side lies on the circumcircle. That's a property in properties of triangles. You have done the proof in properties of triangles chapter. So take this as a property. So we won't be deriving this, but if you go into any standard textbook on properties of triangles, in the topic of orthocenter, you'll have the derivation of this property. The image of orthocenter with respect to any side will lie on the circumcircle of the triangle. Similarly, the image of H about this side will also lie on the circumcircle. The image of orthocenter with respect to the side AC also lies on the circumcircle. So now I am going to use this property, and you'll find that the point which is given minus z2 z3 by z1 is also not arbitrary point. This is a very special point. Now in this question, the reverse property is asked. So if you have this point P, if this particular point is given, this particular point is nothing but the intersection of, because this is orthocenter, if you join orthocenter with A and extend this, this becomes the altitude. So if you take a point at which the altitude meets the circumcircle, the image of this point will be the orthocenter. So it doesn't work for any other point. If it doesn't work for this point. So if you take this point, the image will not be the orthocenter. So whose image will be orthocenter? The point where the altitude meets the circumcircle. The image of this point with respect to this particular side will be the orthocenter. Now what I'm going to prove is this point is exactly that point where the altitude meets the circumcircle. So that can be very easily proved. Let me do this. So let this complex number be z. Let us assume that you draw an altitude from A onto BC. So let us assume that that meets the circumcircle at point z. So now what are the conditions that this z has to satisfy? So first, z minus z1 divided by z2 minus z3. The argument of this has to be equal to pi by 2, right? The argument of z minus z1 by z2 minus z3 should be equal to pi by 2, because the argument of this vector and this vector should differ by pi by 2 units, or I can write it as mod pi by 2 plus or minus pi by 2. This implies z minus z1 by z2 minus z3 has to be purely imaginary right? Has to be purely imaginary. This implies this vector, this complex number plus the conjugate complex number has to be equal to 0, because if a number is purely imaginary, the complex number plus its conjugate becomes equal to 0. So z minus z1 by z2 minus z3 plus z minus z1 bar by z2 bar minus z3 bar is equal to 0, right? But we know that mod z1 is equal to mod z2 is equal to mod z3 is equal to 4. This implies z1 bar is equal to z2 bar is equal to z3 bar is equal to 16, right? Each of this is equal to mod of z1 square, mod of z2 square, mod of z3 square, all are equal to 4. So now instead of z2 and z3, can I write this z2 bar as 16 by z2, 16 by z3, right? This is z minus z1 bar, and this z also lies on this circle. This z also lies on this circle, so z bar should also be equal to 16, right? So if I use all this in this expression, let us see what happens. This implies z minus z1 by z2 minus z3 plus, this is 16 by z bar is 16 by z, 16 by z1, 16 by z minus 16 by z1 divided by 16 by z2 minus 16 by z3 should be equal to 0. So let us try to simplify this further. This implies z minus z1 by z2 minus z3 plus the 16 everything will get cancelled out, z1 minus z by z3 minus z2 into z2 goes up if you take LCM, z2 by z1 is equal to 0. So now what I take is, I can take z minus z1 by z2 minus z3 as common. So z minus z1 by z2 minus z3, if I take this as common, so this is this, if I reverse z minus z1 by z2 minus z3, minus sign gets cancelled. So you have 1 plus z2 z3 by z1 is equal to 0. So this is not equal to 0 because z is not same as z1. Z and z1 are different. This implies z2 z3 by z1 is equal to minus 1 and z is equal to minus z2 z3 by z1. Z is equal to minus z2 z3 by z1. So is this point same as this point? Yes, it has been intentionally given. This point is exactly the point of intersection of altitude with the circumcircle. Now, once we made sure that this is the point, you have to remember this from next time. So this is a very special point, minus z2 z3 by z1. So now once we know this, what is the image of this point about the side BC? That is nothing but the orthocenter. So we need to find the orthocenter of triangle ABC. So how do you find the orthocenter? There is no particular formula for finding the orthocenter. So what I do is, I'll try to find the centroid and the circumcenter, and from section formula I'll try to find the orthocenter. So we know that OGC, orthocenter, centroid and circumcenter, divide each other in the ratio 2:1. So now what is the centroid of this? Centroid is very easy to find. Centroid is nothing but z1 plus z2 plus z3 by 3. And circumcenter is very easy to find because the circumcenter is nothing but the center of the circle, which is the origin, which is 0. So using these two, can I find the orthocenter? Orthocenter divides GC in the ratio 2:3, right? 2:3. So orthocenter is equal to 2 times centroid minus 3 times plus minus 3 times 2 times the circumcenter minus 3 times the centroid divided by 2 minus 3 is minus 1. That's nothing but 3 times the centroid. That is equal to Z1 plus Z2 plus Z3. So the image is Z1 plus Z2 plus Z3. Thank you.